1338, April 15th, 2025, Red Max 972 hours of progress on the global horror simulation. Currently, some modifications to the code have been made, such as printing the positions of every vertex that a mesh contains, and this is being done accurately by getting the vertex data relative to its position in world space rather than local space. It was being done through local space before, just using default, getting vertex positions by default, but that was found to not be correct, as what would occur was that there are two meshes within the FBX scene in Blender, and since they're both the exact same object with the exact same dimensions, the scale not being changed or anything, what occurred was getting the relative positions of vertex data would get that position relative to the object's position in local space, which means that basically it's not about its position in the world, but its position according to the object's origin, or just 0, 0, 0 relative to that node. Now, getting it via world space actually gets the correct position, so this is printing the position of the red monkey head, and that position is different than what was being shown before, which was the blue object. And so another benefit of this was that an actual mistake was discovered within naming the objects, as there's a period there which should not be visible, so that can be fixed at the current moment, and this is being done creating the objects in Blender and then loading them into a custom C++ project using the FBX SDK, and that allows one to actually read the model data directly. And so the intention for the next hour, now that the correct positions seem to be getting read from the variables and stored in a format that could be usable by a graphics engine, where the positions are stored within a vector34 float, and the UVs are stored within a float2 or vec2 data structure. The intention for the next hour is to actually export the file in order to test if this is being done correctly, as what game engines require for at least pixel shaders. Pixel shaders expect data to be from 3D models to be every vertex to be a triangle, and so or at least any good 3D graphics API or 3D model loading and exporting, or just 3D model manager API expects to have a bit of code that triangulates the model, because it could be quads or n-gons, which means basically faces or sides that have more than 3 bits of geometry, so they could have 4 or more, and so basically the triangulation process reduces that down to a triangle. And so the intention here is to just test this, as it's just being loaded into memory and triangulated, and the intention is to actually export it back and then load it into Blender, a different version of this scene, in order to test that the geometric data is being processed, as usually these APIs default calls require just a few additional steps, but this could be good, or it might need some additional steps in order to get the intended program behavior, which is to load the data and parse it correctly and read it directly, so that it can be moved into a DirectX graphics engine.